In this lecture, we will distinguish among the standard deviation of a population, the standard deviation of a sample used to estimate a population standard deviation, and the standard deviation used to describe a sample. Also, we will know and be able to describe the meaning of sigma, S hat, and capital S in statistical use. There are 4 characteristics of a standard deviation you should know. First, the standard deviation describes how the values in a dataset are spread out over the range. Second, you can think of the standard deviation as the average difference between the values and the mean, that is, the average deviation. Third, the larger the standard deviation, the more spread out your values are. And finally, the standard deviation is always greater than or equal to 0. That is, it can't ever be negative. And we'll see why when we do the calculations next lecture. This graphic is an example of 2 samples with the same mean and different standard deviations. The red sample has a mean of 100 and a standard deviation of 10. The blue sample has a mean of 100 but a standard deviation of 50. Both samples, however, contain 1,000 values. So you can tell that the area underneath these curves, so all of the red compared to all of the blue, if you could compare those directly, they would be the same, because the area under the curve, or the area of the shape in this case, is a reflection of the number of values in its sample. One of the things in statistics that can get confusing is there are picky distinctions between whether you're measuring a population, estimating a population, or measuring a sample. In this text, Spatz uses Greek letters specifically when discussing a measured population value. For example, the ACT is published and scored by the College Board. Because all scores must go through their system, they can calculate true population data for the scores each time it is administered. Thus, it would be possible for the College Board to publish the mean, median, mode, and other descriptive values for the entire population of ACT test takers. In inferential statistics, though, it is much more common for the population parameters to be unknown. In fact, that's really the entire point of inferential statistics, is to make estimates of these unknown population characteristics. In tests of inference, one would use a measured standard deviation from a representative sample to infer the value of the population standard deviation. In this example, the measured sample statistic for the standard deviation is represented with a capital italicized S, whereas the estimated population statistic, it's not a parameter because you don't actually know if your estimate is accurate. This estimated population statistic is represented by a lowercase s with a little caret above it. We call that S hat. Some texts and resources don't make a clear distinction between these 3 symbols and their meanings, but in reality, Spatz uses them correctly in this text, so we're going to try to do that also. Let's try practicing some of these by looking at scenarios and deciding which symbol we should use for the standard deviation. A teacher sets an exam for her pupils. The teacher wants to summarize the results the pupils attained as a mean and standard deviation. Which standard deviation should she use? In this case, the answer is actually a population standard deviation. The reason is the teacher is only interested in her particular class of pupils' scores and nobody else. So the population is actually defined as her pupils in this particular class. If she were trying to generalize to all the students in the same class across the school, even with different teachers, the answer would be a sample standard deviation. but because she's not interested in generalizing, it is a population standard deviation. This is represented by the Greek lowercase sigma. In a second example, a researcher recruited males aged 45 to 65 years old for an exercise training study to investigate risk markers for heart disease, for example, cholesterol. Which standard deviation would most likely be used? The answer is the researcher would want to calculate a sample standard deviation. Although it's not explicitly stated, a researcher investigating health-related issues will not be simply concerned with the participants of his or her study. These researchers will want to know how their sample results can be generalized to an entire population. In this case, the population is males aged 45 to 65 years old. Hence, this researcher's descriptive should be a sample standard deviation, represented by a capital italicized S. Let's take the same example from the previous slide on the next step. Now the same researcher uses that sample standard deviation he or she calculated to estimate the population standard deviation for all males 45 to 65 years of age, because that's the population he or she defined. In this case, the researcher would use S hat, the estimated population standard deviation, because the point of the research is to make a generalized statement about a larger population from whom the sample represents. In our last example, let's look at one of the questions on a national consensus survey, which asks for the respondent's age. Which standard deviation would be used to describe the variation in all ages received from the consensus? In this case, you would actually be able to report this value as a population standard deviation, because a national consensus is used to find out information about the nation's citizen. By definition, it involves the whole population. Therefore, a population standard deviation would be used.